Now let's talk about lesson 8.5 a little bit. This is not going to be a major section in the standard, but it does have one important idea that I want you to understand, okay? But there's not necessarily a lot of practice, not really a new procedure to learn or anything, but just a key understanding about the nature of some of the functions that we've been studying, okay? And so what I want to do is I want to put up here the three types of functions we've primarily focused on: linear, exponential, and now quadratic, okay? And I've got an example of each type of function here underneath of them. And then I have a t-chart under each as well with a third column that's the rate of change, right? So as I go through the linear one, this should start to make a little sense, or at least look a little familiar to you about what we've done in the past with these things, with rate of change. All right, so if I put 0 into my function, my y value is 0. So let's fill out the whole y column. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 9, 3 times 4 12. All right, so what I'm doing is I'm always setting it up that I'm increasing my x by 1. So the question is, how is y changing here? Okay, well, you guys can figure it out. You're adding 3 each time. But what's the rate of change? So we're not going to do it with the first one because we need to take two ordered pairs to calculate rate of change, right? Remember the whole y2 minus y1? So 3 minus 0 would be 3 over 1 minus 0, which is 1. 3 over 1 is 3. If we do that with the next one, 6 minus 3 is 3. 2 minus 1 is 1. We get a rate of change of 3. Same thing here. 9 minus 6 is 3 over 1. Get 3. 3. Okay? So notice the rate of change of a linear function is constant. Rate of change equals constant. So with the line, that slope, that rate of change never changes throughout your whole function. It's always your line. It's always a constant rate of change. Okay? Now with exponential, here we go. 2 to the 0 power is 1. I need a better marker. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. Okay? So now let's do our rate of change. Nothing for the first one. 2 minus 1 is 1. Over 1, we get a rate of change of 1. 4 minus 2 is 2. Over, again, 1 would give us 2. 8 minus 4 is 4. Over the 1 gives us 4. 16 minus 8 over the 1 gives us 8. What is the pattern we see here now? It's definitely not constant, right? This one went up by 1. This one went up by 2. This one went up by 4. Right? So it's not always going up by the same amount either. But what I hope you do see is, look at this. You see how those numbers match up? Okay? This one's always going to be kind of one behind where these were. But basically we say the rate of change, because it follows that same pattern, remember this was an exponential pattern, we say the rate of change is exponential. Okay? So for an exponential function, the rate of change is also exponential. It's kind of interesting. Okay? And again, what we have talked about is the importance of exponential, meaning that you multiply by the same amount each time. Okay? You're always multiplying by that constant number, right? That was important. We've discussed that. But if you look at the rate of change, describing that rate of change, we could simply say it is an exponential rate of change. Okay? Now, here's where this lesson is focused on quadratics. So let's put it in. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. Just thought it'd be fun to add another one there. Let me grab a different marker. That one seems to be ending on me. All right. So what's the rate of change? 1 minus 0 is 1 over 1. The rate of change there is 1. 4 minus 1 is 3 over 1. Gives us 3. 9 minus 4 is 5 over 1. 7. 25 minus 16 is 9. So what's happening here? Well, you probably see the pattern. This one's going up by 2, up by 2, up by 2, up by 2. So how do we describe a pattern that's increasing by the same amount every time? Well, folks, that idea is just a linear idea, right? Isn't that how our linear function worked? Not rate of change of that, just the linear part, right? It went up by a constant, went up by 3 every time. That's what's happening there. It's going up by 2 every time. It's linear. The rate of change is linear. Now again, I'll mention some calculus here. I mentioned that in the last video. Calculus, you learn about something called derivatives. And it's really interesting. Derivatives have to do with this rate of change. Okay? And once you've taken calculus, this begins to make a lot of sense, because when you take the derivative of a quadratic function, like the derivative of this function here, you would learn to be y equals 2x. Well, 2x is a linear equation. So you actually come up with that formula using calculus, which is kind of cool. So that's where you guys will head to next. Not all of you, but some of you, if you take that next year. So that's all I need to say with that. You're going to do a few different types of problems with that idea. And probably on the assessment as well, I will ask you to describe this basic idea. So know that for linear, rate of change is constant, exponential rate of change is exponential, and for quadratic, rate of change is linear. That's kind of key. So that's all I got for you. Get to work.